Hello, this is Ms. White at RYSS. I'm making a video to show civil engineering students how to fill out a water pressure form equation sheet or spreadsheet to help take a lot of the extra work out for when you're trying to figure things out for the civil engineering class. So, in this video or in class, there is, or not in the video, sorry, in the comments of the video, there's a link to the template of this spreadsheet. And this is what it'll look like when you see it. It is a Google Sheet. You'll need to make a copy of your own before you can actually type anything in it. So make a copy for yourself first. And I need my phone to stop making noises at me. So make a copy for yourself first before you do anything else. So go ahead and pause the video, make a copy for yourself, and I will start getting this going. I am going to use the same question that I used as an example to do how to do this by hand with my class, which, if you do PL2W, is the second question on the residential water supply part. Now, in this video, I am not going to do the second floor. I will make a separate video for how you do the second floor. So don't worry that you're going to be sitting there bogged down trying to how does second floor what? No, the idea is that I'll do a second video that's second floor that'll actually take a bit less time because we're going to end up copying this tab. But anyway, okay, so we have been given this problem that a facility that receives water at an elevation of 350 feet and the water meter is 4.1 miles from the water tower. The water level of the water tower is 527. The water flow rate is 110 GPM. Assume an 8-inch ductile or cast iron pipe with flange fittings. And then they give this list of what the supply line has. Okay, that's a lot of information to try to throw at you at the beginning. Yeah, and I bet you're also looking at this formula going, what the? Don't worry. That's why we're doing this here with the Google Sheets so we can see it all. Okay. So we're going to put in the information that is given to us in the problem. Now, for those of you guys that have not seen how these spreadsheets are usually set up before, there is an actual color code to these spots. And I've got the color code written over here. If it's blue, there are words that are going to go in there. If it's this pinky orange, there are numbers that are going to go in there. And if it's yellow, there are formulas that are going to go in there. Once we have created the setup for this spreadsheet, you will never change the yellows again. I repeat, once you have made this spreadsheet, you will never mess with the yellows again. The only things that will change are the blues and the pinky oranges. Okay, so let's put in the information we have been given. It says the elevation of the water tower is 527 feet. So right there, water tower elevation, 527. Enter. The elevation of the site, it says, is 350 feet. 350 feet. Cool. The mileage in feet is how far away is the site from the water tower. And they told us it's 4.1 miles. Yes, this says miles in feet. Don't worry about it just yet. Then they also tell us what the fittings are. They say we have 90-degree elbows. We have gate valves. We have line flow tees. Branch flow tees. And a swing check valve. So that's just to help keep track of what that is. Also, written in the problem tells you how many they are. So this QTY, quantity, it says that we have 2 of this one. We have 2 of that one. We have 17 of that one. We have 6 branch flow tees and 1 swing check valve. Okay? And it says that our flow rate is 110. We don't know the constant yet. and the pipe diameter is 8 inches. So those are all the numbers, things we have been given in the problem. Whenever you do a problem, these are the things that should be able to be filled in from what you are given. You may not have this many of these. You may have more types, in which case you'll need to do an insert line, one of these where you like right click, insert a column or insert a row above, and make sure you copied the formula down from the one above it. But for this one, this is all we need. And if you don't have as many, then you just leave those blank. Okay, so whenever you solve the problem by hand, we're going to do this in the order that we would do it by hand. First thing we do is we calculate the static head. So here is your static water head. So what your head is equals, I'm going to go ahead and click the water tower, so the source, height, elevation, minus the site elevation. So J2 minus J3. I know it might be a little hard to see on the screen, so I'm going to say it out loud. J2 minus J3. And if you hit enter, you should have 177. So that's the first step. That's it. That's the whole first step. Yay. Second step is you then turn that one into pressure, so PSI. All you have to do for that one is make sure you click the cell, equals. You got to click the one before it, the static water head, that 177, so J16, divided by, or slash, 2.31. Because that is how many, that's the conversion between head and PSI, head of water and PSI. That's just what it is. So if you hit enter, ooh, that got spread out a bit. Let me show you a fun little trick here. I'm going to go ahead and highlight this column. And if you look up here at the top, you see the 0.0 with an arrow going left, or 0.0 with a 0 with an arrow going right. That's talking about increasing or decreasing the precision of what's there. So actually, I'm not going to select the column. I'm going to select all the yellows. So I'll do it for these ones first. Actually, I'll do those ones after once I actually have numbers in there. So let's do these ones first. And if I click to the right, let's put it at 2 decimal places. So that's all that does, is it changes how many decimal places out you see. Nice and quick, simple to make it do it. Okay. Now, we need to find the head loss. This is where this big ol' annoying formula comes in. So, first thing, we already got the Q. That's what that flow rate is. See, Q, flow rate. D is the pipe diameter, so we already have that. So we got to find these other two things. First one is this. The first and easiest one is this constant. We'll get back to these, don't worry. This constant. So I've put the table on this sheet. In the problem, it tells us that it is ductile or cast iron pipe. So this is where we're going to use this table right here. You can't see it, this table. So cast iron is the first one on the column, the first row. And if they haven't specifically told us it's new, we use the typical value. That's straightforward. If it's not new, it's typical. So for a typical cast iron pipe, the value is 100. So I'm going to put that right here where it says constant. 100. Hey, there, that's the C. That part was easy. Here's where it starts to get annoying. The effective length of the pipe, and that's that L. And it needs to be in feet. So let's do the easiest part first. Let's change that 4.1 miles into feet. So there's 5,280 miles in a foot, or feet in a mile, I mean. So we do equals I4. That's what this column is. I usually just click it. I don't usually type it. Times, if you're not sure which thing you use times, you do Shift 8 to get that star shape. 5280. So that's I4 times 5280. If you hit enter, you should get 21,648. Okay, so that's the easy part. The other ones are a little more annoying. So all of the bends and elbows and fittings that happen in your pipe, slow it down as if it had gone through more pipe. Now, luckily, somebody else has figured out how much that equivalent is. So we look at each. So the thing we have to do is we go down to this table that I've also attached. Yay! So we're told in the problem that it's a pipe with flanged fittings. That's this fit right there, flanged fittings, and that it's an 8-inch pipe. So this is your 8-inch column. I didn't mean to drag that. I was just trying to make sure that I had the highlight circle. So we're going to look up what each of these fittings were and put what number we find on this table. So we got a 90-degree, and it's 12. So it's a 90-degree to bend is the equivalent of 12 feet. So we go back up here, 90-degree elbow, 12. Then we got, let's see, a gate valve. We go on this table, elbows, T's, bends, valves. Gate valve is the second one, 3.2. So 3.2. Line flow T. So T's, line flow is the first one, 4.7. Branch flow T. T's, branch flow, 824. And then the swing check valve. Valves, swing check's the one on the bottom, 90. Now, if you notice, all the orange ones, pinky orange ones are now filled in. So the only thing we have left to do on here is formulas. If this was a brand new question you were doing and you already had your spreadsheet set up, you'd have your answers already. So let's get our formulas in. So the formulas that go here are very easy. This one that go alongside where the blues are is we just do equals the H column. So H5 for this one because we're on row 5 times the I column. So I5. So this one's H5 times I5. And you're going to fill that by when you see if you mouse over the little ball there in the corner, it becomes a plus sign. You can grab it and drag it so it will fill the ones below it with the same formula, but adapting to the new row. So you see this one is H5 times I5. This one's H6 times I6. H7 times I7. It's smart enough to be able to adapt that. H9 times I9. Make sure that's actually happened. Don't just type these numbers in. Otherwise, your spreadsheet will always just say those numbers and you won't be able to get the answers. Okay. So that filled those in. And then the total length, we just do equals sum. It's trying to fill it in for me, but it's wrong. It's trying to go all the way up to row 2 where the elevation is. Sum, open the parentheses. It's going to be J4 colon J9. So J4 colon J9, and then close the parentheses. Sum, that's SUM, open the parentheses, J4 colon J9, close the parentheses. And you should get 21992.3. We shouldn't be getting really weird long numbers here, so I'm not actually going to bother with my little increase, decrease decimal places bit. Okay, so this entire top part here is done. It's ready. This is where then here's where we put the ugly formula. This is the ugly formula. Yeah. Okay, so keep with me. I'm going to try to see if I can zoom in to make this easier to see as I type it. Okay, so you're going to do equals. That part's easy at least. 10.44 times, let's see, 10.44 times the equivalent length. So your equivalent length is this one that just got calculated here. So I'm going to go ahead and click it, which is J10. Yes, this formula moves around with me as I'm scrolling around. So equals 10.44 times J10 times, and this is where it gets weird, open the parentheses. Let's see. Here we go. Open the parentheses, and now we need the flow rate. So J11, close the parentheses, caret. That's what it's called. When you do shift 6, that is called a caret. 1.85. We're only partway down here. Divided by, open parentheses, your constant with your C, so this one, J12, caret 1.85 times your pipe diameter, so J13, caret 4.8655. Close the parentheses. This is the formula you should put in. I'll leave it up here for a moment so that you can get a better look at it and you can see it. That is the formula you are putting on the line that says head loss. Make sure you pause the video if you're not sure. Go back, pause. Make sure you've got that in there correctly. Because this is what the rest of the stuff all hinges on. Okay. If you hit enter, you should get 11.06. Woohoo! So luckily, the next bits are easy. Your dynamic water head at the first floor. All you have to do is equals your static water head, so that's J16, minus the one you just did, J18. So J16 minus J18, that's it. Enter. Your total dynamic head. That's, I don't know why they call it that, because it could also just be called your actual pressure or your dynamic pressure. Civil engineering terminology can be a little weird, but we're looking for the pressure. We're actually trying to find the PSI here. So we're going to do the same thing we did for that static water pressure. We're going to do equals. No, we're not going to sum it. This is a Google Sheets trying to be smart and not succeeding. We're going to equals the J19 divided by 2.31. So J19 divided by 2.31. Enter. Okay, so this last bit is, does it meet the requirements for it to be safe? This is actually going to use a little bit of programming knowledge of an if-then statement. Basically, if this is true, then say this. If it's not true, then say this. So I'm going to go ahead and show you how to set this up. So equals if, open parentheses, and open parentheses. Gotta love the formats for Excel and Google Sheets. So what I'm basically saying, if both of these things I'm about to put in here are true. So if that total dynamic head, the J20, is greater than or equal to 40, because remember it has to, minimum is 40 it can be to be safe, comma, and J20 is less than or equal to 80. That's how you do those. Greater than or equal to, you just do the greater than sign and an equal sign. Less than or equal to, less than sign and equal sign. So I'm saying if it's true that it is between 40 and 80, you cannot in Google Sheets or Excel do a compound inequality. It's just not how the programming, the format for it works. So we got that. Comma. You need a comma. If it is true, quotes, yes, end quotes. Comma. If it is not true, quote, no, end quotes. Close parentheses. That's the whole thing. It's just saying if it's between 40 and 80, yes, it's safe. If it's not, no, it's not safe. Leave that up there for the moment. And enter. And now it's all set up. That's the whole thing. Whole thing's there. Now if I went into another problem, all I'd have to do is change what's here in the pinky orange and the blue, not touch the yellows, and it'll give me my answers right there. Doesn't that make life easier?